6.3 from the chapter Triangles. So in the second question, they've given that in figure 6.35, triangle ODC is similar to triangle OBA, and angle BOC is equal to 125 degrees, and angle CDO is equal to 70 degrees. They're asking us to find DOC, angle DCO, and angle OAB. So they've given that the triangles DOC is similar to triangle OAB. That means the corresponding angles for both the triangles will be equal. And we will also notice that in the line DB, angle DOC and COB are supplementary angles. So that means angle COB, which is 125 degrees, will add up, plus DOC will add up to 180 degrees. And since we also know that the corresponding angles are equal, so we can say that angle CDO is equal to angle OBA, angle DCO is equal to angle OAB, and since angle DOC and AOB are vertically opposite angles, so they will be equal, so angle DOC is equal to angle AOB because they are vertically opposite. And as I mentioned before, angle DOC and angle COB are supplementary angles, so we can say that angle DOC plus angle COB is equal to 180 degrees. And we know that angle COB is 125 degrees, so angle DOC is equal to 180 minus 125, and DOC is equal to 55 degrees. So now we know the value of DOC, so we can write angle DOC is equal to 55 degrees. Now we need to find the values of DCO, and since we already know two of the other angles in the triangle, we just need to find the other angle of the triangle, and we know that all angles in a triangle add up to 180 degrees. So in triangle DOC, angle 70 degrees plus angle 50 degrees plus angle DCO is equal to 180 degrees. 70 plus 555 is equal to 125. So 125 plus angle DCO is equal to 180 degrees. And angle DCO is equal to 55 degrees. So now that we know the value of DCO, we've already mentioned that angle DCO is equal to OAB because they are corresponding angles. And we know that DCO is equal to 55 degrees, and since DCO is equal to OAB, we can say that OAB is also equal to 55 degrees. So the value of all the angles that they've asked us to find are 55 degrees. In the third question, they've given that diagonals AC and BD of a trapezium ABCD with AB parallel to DC intersect each other at point O. Using the similarity criterion for the two triangles, show that AO by OC is equal to OB by OD. So they've given that AB is parallel to DC. That means we can say that lines AC and BD, the diagonals of the trapezium, are transversal lines between two parallel lines. And they've asked us to prove AO by OC is equal to OB by OD. And since the lines AC and DB are transversal lines, that we can say that angle ABO is equal to angle BDC because they're alternate interior angles, and angle BAC is equal to angle ACD since they are alternate interior angles. So we can write that angle ABD is equal to angle BDC, and angle BAC is equal to angle ACD. So this is in triangles ABO and triangle DOC. And we will also notice that the angle AOB and DOC are vertically opposite angles. So they are equal. AOB is equal to angle DOC because they are vertically opposite. And these two angles are equal because they are alternate interior angles. Now that we've proved that all three of the corresponding angles in both the triangles are equal, we can say that using the angle property, that the triangle AOB is similar to triangle COD. So since the two triangles AOB is similar to the triangle COD, we can say that its sides are in equal ratios. So that means AO by CO is equal to OB by OD, which is equal to AB by CD. And in the question they've asked us to prove AO by OC is equal to OB by OD, and we've already proved that over here, so we can say hence proved. In the fourth question, they've given that in figure 6.36, QR by QS is equal to QT by PR, and angle 1 is equal to angle 2. We need to prove that triangle PQS is similar to triangle TQR. So they've given that angle 1 is equal to angle 2. So they've given that angle PQR is equal to angle PRQ. And since both of these angles are equal, we know that these sides opposite to equal angles are equal. Meaning, since sides opposite to equal angles are equal, we can say that QP is equal to PR. And they've given that QR by QS is equal to QT by PR. And we know that PR is equal to QP. So we can substitute the values of QP here. So we will get QR by QS is equal to QT by QP. And in triangle PQS and triangle TQR, we've already proved that QR by QS is equal to QT by QP. So basically QR by QS is equal to QT by QP. And angle Q is the same in both of the triangles. So angle Q is equal to angle Q. By the SAS property, we can say that triangle PQS is similar to triangle TQR. In the fifth question, they've given that S and T are points on sides PR and QR, and triangle PQR such that angle P is equal to angle RTS. We need to show that triangle RPQ is similar to triangle RTS. So they've given that angle RTS is equal to angle RPQ. And we need to prove that the triangle RPQ, this whole big triangle, is similar to the smaller triangle RTS. So they've given that angle RTS is equal to angle RPQ. And we also know that angle SRT is equal to angle PRQ in triangles RST and triangle PRQ. We know that two of the angles in both of the triangles are equal. So using the AAA property, using the angle property, we can say that triangle RPQ is similar to triangle RTS. SRT is equal to angle PRQ because R is the common angle in both triangles. So we can say that triangle RPQ is similar to RTS. In the sixth question, they've given that in figure triangle ABE is congruent to triangle ACD. we need to show that triangle ADE is similar to triangle ABC. So they've given that triangle ABE is congruent to triangle ACD. So using the CPCT in triangles ABE and triangle ACD, we can say that by CPCT, AB is equal to AC and AD is equal to AE. And we can divide both of these equations, AB is equal to AC and AD is equal to AE, in order to prove that they are equal. So in triangle ADE and triangle ABC, we can divide both of these equations. So we will get AD by AB is equal to AE by AC. Moreover, in both of the triangles, angle A is common for both of them. So angle A is equal to angle A in both triangles. So using the SAS property, we can say that triangle ADE is similar to triangle ABC. In the seventh question, they've given that in the figure, altitudes AD and CE of triangle ABC intersect each other at the point P. We need to show that in the first question, they're asked us to show that triangle AEP is similar to triangle CDP. So first, we will notice that angle CPD is equal to angle APE because they are vertically opposite. Next, we can see that angle CDP and PEA are both angles that equate to 90 degrees. So angle CDP is equal to angle PEA, which is equal to 90 degrees. So using the angle-angle similarity criterion, we can say that triangle AEP is similar to triangle CDP. In the second question, they're asking us to prove that triangle ABD and CBE are similar. So first we will notice that angle ADB is equal to angle CEB because they both equal to 90 degrees. Second, we can say that angle ABD is equal to angle CBE because they are both common angles in both the triangles. So angle B is common for both of those triangles. So we can say that two angles are equal. So we can say that by angle-angle criterion, triangle ABD is similar to triangle CBE. In the third question, they're asking us to prove that triangle AEP and ADB are similar. So angle AEP would be equal to angle ADB because they are both equal to 90 degrees. Moreover, angle PAE is equal to angle DAB because they are both common angles. By the angle-angle criterion, we can say that triangle AEP is similar to triangle ADB. In the fourth question, they've given that angle PDC and angle BEC are similar, so we need to prove that they are similar. So we can say that angle PDC is equal to angle BEC because they both equal to 90 degrees, and angle PCD is equal to angle BCE because they are both common angles. So using the angle-angle criterion, we can say that triangle PDC is similar to triangle BEC. In the eighth question, they've given that E is a point on the side AD produced of a parallelogram ABCD. and BE intersects CD at F. We need to show that triangle ABE is similar to triangle CFB. So we will notice that in this diagram, that angle DAB would be equal to angle FCB, because DC is parallel to AB and the lines CB and angle DA are also parallel. So the figure DABC form a parallelogram. So the opposite sides of a parallelogram will be equal. So we can write that in triangle ABE and triangle CFB, angle A is equal to angle C because they are the opposite sides of a parallelogram. Next, we can say that angle AEB is equal to angle CBF. So angle AEB is equal to angle CBF, because they're alternate interior angles, as AE is parallel to BC. So we can write that angle AEB is equal to angle CBF because they are alternate interior angles, because AE is parallel to BC. Next, we can say, since we've proved that both of the angles in two triangles are equal using the angle-angle property, we can say that triangle ABE is similar to triangle CFB. In the ninth question, they've given that in the figure ABC and AMP are two right triangles, right angled at B and M, respectively. We need to prove that triangle ABC is similar to triangle AMP. So we can say from the figure that in both of the triangles, angle CAB is equal to angle MAP because they are both common angles. Next, angle ABC is equal to angle AMP because they are both equal to 90 degrees each. So using the angle-angle criterion, we can say that triangle ABC is similar to triangle AMP. In the second question, they're asking us to prove that CA by PA is equal to BC by MP. Since we've already proved in the first question that triangle ABC is similar to triangle AMP, that means their corresponding angles are also equal. So since we've already proved that triangle ABC is similar to triangle AMP, that means if two triangles are similar, then their corresponding sides are always equal. In the 10th question, they've given that CD and GH are respectively the bisectors of angles ACB and angle EGF, such that D and H lie on the sides AB and FE of triangles ABC and triangle EFG, respectively. If triangle ABC is similar to triangle FEG, we need to show that CD by GH is equal to AC by FG. Since they've given that triangle ABC is similar to triangle FEG, we can say that angle A is equal to angle F, angle B is equal to angle E, and angle ACB is equal to angle FGE. And since angle ACB is equal to angle FGE, we can say that angle ACD is equal to angle FGH because it is the angle bisector. Moreover, angle DCB is equal to angle HGE, also because it is the angle bisector. And in triangle ACD and triangle FGH, angle A is equal to angle F, and angle ACD is equal to angle FGH. So we can say that triangle ACD is similar to triangle FGH due to the angle-angle similarity. So if triangle ACD is similar to triangle FGH, we can say that CD by GH is equal to AC by FG. In the second part of the question, we need to prove that in triangle DCB and triangle HGE, we already know that angle DCB is equal to angle HGE because we already proved that in the first question. Moreover, we know that angle B is equal to angle E, which we've already proved as well. And in triangle DCB, we can say that it is similar to triangle HGE due to the angle-angle property because we've already proved that angle DCB is equal to HGE and angle B is equal to angle E. So using the angle-angle criterion, we can say that triangle DCB is similar to triangle HGE. In the third question, we can say that in triangle DCA and triangle HGF, angle ACD is equal to angle FGH. We've already proved this. Moreover, we already know that angle A is equal to angle F. Using the angle-angle criterion, we can say that triangle DCA is similar to triangle HGF. In the 11th question, they've given that in the following figure, E is a point on side CB produced of an isosceles triangle ABC, with AB is equal to AC, and AD is perpendicular to BC, and EF is perpendicular to AC. We need to prove that triangle ABD is similar to triangle ECF. So since ABC is an isosceles triangle, we can say that AB is equal to AC. And if AB is equal to AC, that means angle ABD is equal to angle ECF. So in triangle ABD and in triangle ECF, we know that angle ADB is equal to angle EFC because they both equal to 90 degrees. And angle BAD is equal to angle CEF. And we've already proved this. So using the angle-angle criterion, we can say that triangle ABD is similar to triangle ECF. In the 12th question they've given, the sides AB and BC and median AD of a triangle triangle ABC are respectively proportional to sides PQ and QR and median PM of triangle PQR. we need to show that triangle ABC is similar to PQR. So in the question they've given that AB by PQ is equal to BC by QR, which is equal to AD by PM. And in both the triangles ABC and triangle PQR, we need to prove that they are similar. So they've already given that AB by PQ is equal to BC by QR, which is also equal to AD by PM, right? And in order to prove that ABC is similar to PQR, we need to prove that AC by PR is equal to the following ratios: AB by PQ, which is equal to BC by QR, which needs to be equal to AC by PR. We need to prove that in order to prove that triangle ABC is similar to PQR. So when we divide BC by half, we will get BD, right? So when we divide BC and QR by half, and since D and M are respectively the midpoints of BC and QR, when we divide it by 2, we will get BD by QM is equal to AD by PM. So that means triangle ABD is similar to triangle PQM. And if they are similar, that means their corresponding angles will also be similar. So angle ABD would be equal to angle PQM. So we've already proved that angle ABD is equal to angle PQM. So in triangle ABC and angle PQR, we can say that by the SAS property that they are similar, because angle B and angle Q are equal, and they've already been given that AB by PQ is equal to BC by QR. So since we've proved that angle B is equal to angle Q, we can say that by SAS they are both similar. In the 13th question, they've given that D is a point on the side BC of a triangle ABC such that angle ADC is equal to angle BAC. We need to prove that CA squared is equal to CB times CD. So in triangle ADC and triangle BAC, angle ADC is equal to angle BAC. Similarly, angle ACD is equal to angle BCA because they're common angles. And using the angle similarity criterion, we can say that triangle ADC is similar to triangle BAC. And we know that the corresponding sides of similar triangles are in proportion. So CA by CB is equal to CD by CA. When we cross multiply, we will get CA squared is equal to CD times CB. Hence proved. In the 14th question, they've given that sides AB and AC and median AD of a triangle ABC are respectively proportional to sides PQ and PR, and median PM of another triangle PQR. We need to show that triangle ABC is similar to triangle PQR. So first we're going to construct a mirror triangle on the bottom of the given triangle ABC, and where DE is equal to AD and BE is equal to AB and AC is equal to EC. So once we do that, we will notice that both of the diagonals of this new figure, ABEC, they are perpendicular bisectors of each other. And since they are perpendicular bisectors of each other, we can say that this figure is a parallelogram. And if this figure is a parallelogram, that means BE would be equal to AC and QN would be equal to PR. So since they're asking us to prove that triangle ABC is similar to triangle PQR, where we need to prove that AB by PQ is equal to BC by QR, which is equal to AC by PR. So this is what we need to prove. We need to prove that AB by PQ is equal to BC by QR, which is equal to AC by PR. And since this figure is a parallelogram, we can say that BE is equal to AC and QN is equal to PR. We can substitute this in the given values. So we can say that AB by PQ is equal to BE by PR, BE by QN, which is equal to AD by PM. The reason why we get BE by QN is because instead of AC we substitute BE, instead of QN we substitute PR. Instead of PR we substitute QN. So we will get AB by PQ is equal to BE by QN, which is equal to AD by PM. So we're going to multiply AD by PM times 2 so that it will be equal to AE by PM. So we will get AB by PQ is equal to BE by QN, which is equal to AE by PM. So now we will notice that all of the sides in this triangle, in triangle ABE in triangle ABE and triangle PQN, we will notice that all the sides are in equal ratios. Since all sides are in equal ratios, we can say that the corresponding angles are equal. So that means this angle will be equal because it is a corresponding angle. So angle BAD would be equal to angle QPM. And since we proved that angle BAD is equal to angle QPM, we can now prove that AB by PQ is equal to AC by PR, which is equal to BC by QR. So in triangle BAD and triangle QPM, we know that AB by QP is equal to BD is equal to AD by PM, and we know that angle BAD is equal to angle QPM. So by SAS criterion, we can say that triangle BAD is similar to triangle QPM, and since we proved this, we can say that AB by QP is equal to AD by PM is equal to BD by QM. And now that we've got this, we're going to multiply this times 2. And when we multiply this times 2, we will get AB by QP is equal to AD by PM, which is equal to BC by QR. And now we have proved what they've asked us to prove, which is ABC is similar to PQR, and in order for it to be similar, AB by PQ needs to be equal to BC by QR, which is equal to AC by PR. And since they've given that AC is equal to PR is equal to AB by PQ, we can say that this is also equal to AC by PR. Hence proved. In the 15th question, they've given that a vertical pole of length 6 meters casts a shadow 4 meters long on the ground, and at the same time, a tower casts a shadow 28 meters long. We need to find the height of the tower. So we will draw two triangles, and they've given that the height of the pole is 6 meters, the length of its shadow is 4, the height of the tower is h meters, and its shadow is 28. So this will equal 90 degrees, and this would be the angle of elevation. And since they mentioned that both of them happen during the same time, that means the angle of elevation of the shadows would be same. So that means using the AA angle property, we can say that triangle ABC is similar to triangle FED. And since we proved that, that means its corresponding sides are in equal ratio, so we can say 6 by 4 is equal to h by 28. So 3 by 2 is equal to h by 28, where 3 times 28 by 2 is equal to h, and this will get cancelled. So 14 times 3 is equal to h, which would be 42. So the height of the tower would be 42 meters. In the 16th question, they've given that if AD and PM are medians of a triangle ABC and PQR, respectively, where triangle ABC is similar to PQR, we need to prove that AB by PQ is equal to AD by PM. So we know that the corresponding sides of similar triangles are in proportion. So that means AB by PQ is equal to AC by PR, which is equal to BC by QR. And also their corresponding angles are equal. So angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. And since AD and PM are medians, they will divide their opposite sides in two equal parts. So we can say that BD is equal to BC divided by 2, and QM is equal to QR divided by 2. So we will name this as the first equation, this is the second, and this is the third. So from 1 and 3, we will get AB by PQ is equal to BD by QM, which we will name as the fourth equation. So in triangle ABD and in triangle PQM, from equation 2, we can say that angle B is equal to angle Q. And from equation 4, we can say that AB by PQ is equal to BD by QM. So by the SAS criterion, we can say that triangle ABD is similar to triangle PQM. And if triangle ABD is similar to PQM, we can say that AB by PQ is equal to BD by QM, which is equal to AD by PM.